In this video, we're going to see how to perform hypothesis test of the population proportion. And for that, we're going to use data file WomenGolf. So the process of hypothesis testing for population proportion is pretty much the same as the process, the hypothesis testing process for population mean. So we still need to develop null and alternative hypotheses. We again need to specify the level of significance, alpha, which is usually either 1%, 5%, or 10%. Then we need to collect the sample data and compute the value of the test statistic. This is the main difference now. So the test statistic, depending on the type of test that we're performing, is going to be different. I'm going to talk about that in a minute. And then the rest is exactly the same. We find the p-value, we make the conclusion by comparing p-value and alpha. If p-value is small, we go ahead and reject the null hypothesis. And based on that, we make a business conclusion. I mean, we just need to basically make sure that we make the appropriate conclusion in terms of the like business application that we're talking about. So here I have different types of tests: lower tail test, upper tail test, two-tailed type of test. And then depending on the region in which I am rejecting the null hypothesis, the type of test is determined and defined. So for example, here P stands for population proportion, and P0 stands for the hypothetical value for population proportion. All right. For example, the proportion of female golfers in the United States, in the country, that is the population proportion of golfers in the United States that are female, all right? And then hypothetical value can be a number, let's say 20%, 25%, 30%, all right? This is a case of lower tail test because we are rejecting at the lower side of the distribution. This means that if, let's say, the hypothetical value is 20%, we want to test to see if the proportion of female golfers in the United States is strictly less than 20%. So if that is our research question, when we take a sample and find the p-bar sample mean, we only, we can reject the null hypothesis only if the p-bar sample proportion is strictly lower than 20%, if p0 is 20%. If we take a sample and find p-bar and p-bar happen to be, let's say, 25%, we don't have enough evidence to go ahead and reject the null hypothesis. If it's 20%, again, we don't have enough evidence to say if the P population proportion is less than 20%. But if it happens to be 10%, then we can go ahead, depending on the standard error, of course, we can go ahead and say that we may be able to say that it's significantly, the P statistically is lower than 20%. All right, so we need to get a number, a p-bar that is strictly lower than and significantly lower than p0, the hypothetical value. And then the same logic actually applies to upper tail test and two-tailed test. For the p-value, we're going to use the normal standard distribution, and the test statistic now follows a standard error distribution. And that's why we use normal standard distribution for finding the p-value here. But then the process is exactly the same. The only difference would be finding the test statistic. I'm going to copy this I'm going to go to the data file, WomenGolf. So here we have the data file. I'm pasting my formulas here. So, all right, the first step, writing down the null and alternative hypothesis. And this time I'm gonna perform a lower tail type of test. So, and then my hypothetical value would be 20%. So I would say my null hypothesis is that proportion of female golfers is, or let me just put F here, proportion of female golfers is strictly greater than or equal to 20%. And then alternative hypothesis says proportion of female golfers is strictly lower than 20%. Let's say somebody has told us that, has claimed that proportion of female golfers in the country is less than 20%. All right, so if we have this research question, if we're trying to find evidence for this claim, so this is how we set up the null and alternative hypothesis. So that's the first step. The second step would be to define the level of significance. I mean, this is definitely the second step, but that doesn't mean that you have to put it on your Excel file, or it doesn't have to really go with this order when you write it. So you can actually put it at the end, or you may just know it. And when you're writing the conclusion, you use that level of significance, and you don't report it here. That's still okay. But I'm just gonna type it here, 5%. That's again, that is something that is given to us, level of significance. Then I'm gonna go ahead and find this test statistic. For this, I need sample proportion of female golfer. For the sample proportion of female golfers, I need to first count the number of females divided by the frequency of golfers, by the number of golfers in my sample. So I'm just gonna go ahead and find the sample size. I'm gonna need to count the number of females. So response of interest, which is gonna be female count of interest, sample proportion. All right, sample proportion. So I get P bar. Now I also need P0. So hypothetical value P0. And that would be, it's given in the question, it's given in the null and alternative hypothesis. So that would be 20%. So we have P0. Let me just fill out the rest. So sample size is count A of my sample. I already know that my sample has 400 cases, 400 golfers in it. So all right, count of interest, count if the range would be column A, criteria would be the word female, and here you just need to make sure that you don't have any extra space, or I mean, you just want to make sure that the female that you have here is exactly the same as female, the word female that appears here. So you don't want to have any difference here. Otherwise, you will have a count of 0. So that sometimes happens. So you just want to make sure that these words are exactly the same, female and female here. Sample proportion now, out of 400, 100 of them are female, so it's going to be 100 divided by 425%. So it's 25%. I already know that, based on the definition, I got a sample and the proportion is at the right side of the distribution. This 25% is at the right side of 0.20. All right, so that would be here. So therefore, this does not give me enough evidence to go ahead and reject the null hypothesis. It's kind of supporting the null hypothesis. You see, that's what I mean by not being able to reject the null hypothesis. In order to be able to reject the null hypothesis, we should have our p-bar sample proportion at the left side of the distribution. And really at the left side, far from the 0.2. It should be strictly less than 0.2. But it's not the case. So I expect to get p-values that are very low, larger than 5%. It's not going to be significant anyway. So hypothetical value, p0.2, but I'm going to continue anyway. I know the outcome, but still, we're going to keep going. So now I have the hypothetical value. I have the sample proportion. I'm going to go ahead and find this standard error, which is going to be the denominator here in this test statistic formula. So it's going to be standard error, and it's going to be square root of P0 hypothetical value times 1 parenthesis 1 minus P0 divided by sample size n 400. All right, so this is the formula. 0.02, this is the standard error. And now I can go ahead and find the test statistic. Test stat, and it follows a standard normal distribution, and I'm going to use Z to denote that. So I have parenthesis P bar sample proportion minus P0 divided by standard error. So this is my test statistic, Z, and now I can go ahead and find p-value lower tail, p-value upper tail, and p-value two tail. So p-value lower tail, I have the formula here. It's norm dot s dot distribution Z test statistic and true for cumulative. And if I do that, I get 0.99%. And this is exactly what I need. But still, I'm going to keep computing the other ones. So 1 minus p-value lower tail and 2 times minimum of lower and upper tail p-values is going to give me the p-value 2 tail. This is a lower tail type of test. How do we know that? We just look at the alternative hypothesis. We look at the sign of it. It's the lower sign, so that would be a lower type of test, lower tail type of test. So p-value lower, 0.99. And it's, obviously greater than 0.05, the level of significance alpha. So I'm going to go ahead and say, since p-value is, and then again, by p-value, I mean p-value lower tail, since p-value is above or is greater than alpha, and alpha is, again, we assumed is 5%. If you're given with a different number, so you just want to make sure that you're using the right number. And sometimes you're given 1%, sometimes you're given 2%, 10%, all right? So since p-value is greater than alpha, we fail to reject the null hypothesis and conclude that, and we can conclude with 95% confidence that, so if we fail to reject the null hypothesis, so we still, our conclusion has to be in accordance with the null hypothesis. So we are kind of rejecting the alternative hypothesis, right? So I can write my conclusion this way. I can say, I can conclude with 95% confidence that the proportion of female golfers is not strictly less than 20%. So we conclude with 95% confidence that the proportion of female golfers in the US, in the United States, is not less than 20%. Is not less than 0.2. And let me just since p-value is greater than alpha, we fail to reject the null hypothesis, and we conclude with 95% confidence that the proportion of female golfers in the United States is not less than 0.2 or 20%, right? So we don't have enough evidence to support the alternative hypothesis.